Hello and welcome to episode 5 of JESC. So why are coroutines unpredictable? They're not. In this video I want to explain a bit how the last exercise was made and what is the goal behind it. Coroutines are essentially made to make better usage of system threads. In broad terms, coroutines were made to make better usage of our system. What we want to do with coroutines is usually ride the wave of threads and then make sure that we can suspend and resume these coroutines, and when they are suspended they can give room for another coroutine to use the thread. But what we are also concerned when we are programming with coroutines is the predictability of our code. In some situations I have witnessed, and we all experience this, I think, we try to make an implementation with our coroutine, we try our best to pick the one that's better, and many times, more often than not, it seems like it fails when we try to use this, when we try to pick up a scope, or we try to get a good cancellation policy with our coroutines. We just want to be able to predict what kind of result are we going to have. This exercise was made a bit for us to become more aware of how that works. Let's get into the exercise and find out which one of the options A, B, C, or D are the correct one. This is the main program, which is something you cannot see in the exercise itself. In the exercise, we don't really see the full implementation of the program, just the methods that are being called. So here we have the 4 different calls to the different options that we want to investigate and see if they match with what we want to achieve. To illustrate our problem and to show which option was the correct one, I've created a small example which is a bit of associated how cheese is made. So we're going to have these different processes. We're going to have a machine start, a cheese curd making, let it sit, and a make report. Super simple. This is not how cheeses are made, but this is a way to kind of show how this works. So the first example is test launch, and this is representative of option A of our quiz. When we started, we are first running a coroutine in a blocking scope, so there isn't really a difference to our runtime at this point, and this coroutine is going to launch another coroutine in the global scope. The global scope here is a bit of a trap in all of the different options. It doesn't really have an effect in the outcome of what we are trying to achieve. So the first log that we get is that the machine has started, and then afterwards we're going to run another coroutine, and this coroutine we start in the IO context, and there we will start the cheese curd making process. But until this point we've achieved already 2 things. We've started a machine, we've made the curds, and now we're going to launch another coroutine which is going to let the curd sit for a while, and then we're going to generate our exceptions. So this is the point where the exceptions are going to be generated as an equivalent to what we have in our quiz. In this case we're going to join the job that is running on IO, and what this means is that the IO coroutine will be suspended until this job has reached its completion, and then it will resume. But we have already generated an exception, so the exception has already been, because of this join, thrown to the console. And that also means that there will be no on failure being caught. And because of that, this launch here, which is what we want to launch to create a report, has already launched in the meantime. So this means that we already sent a report, the global report, after the exception has been generated. And then finally we just wait for the process to be done, and then we say the process is complete. but here the order has changed and it goes against our expectations. So let's run this to have a visualization of what I mean with this. So we start our process, and now we should see that the machine has started. We started the curd making. Now we're going to let our cheese sit. Here at this point an exception will be generated, but instead of waiting for the exception to be generated, we already sent the report. And of course, then comes the exception to the console. Then we see that the exception has been thrown to the console, but this is the original exception. So the report exception, this one here, an error has been reported, we don't see anywhere in the console, and the reason is because it has not been called. What is happening is that we didn't even call the error report. So we did not send the error report at all. So it's definitely not option A. And just to be very quick about it, so we've created a blocking scope, then inside of it a global scope, which should cater to these two different coroutines, one in dispatchers IO and another one in the same global scope. This runs smoothly until we generate the exception, which then would be caught here, but because we are joining here and suspending the coroutine dispatched by the IO dispatcher, we are not suspending the global scope coroutine, and so it keeps running and it completes the report before the error report has ever been generated. So this invalidates option A. If we go to option B, so then we come to option B. In option B, I have a function that I called it test remove. And in the test remove, what I mean by test remove is that we are not going to use separate coroutines. So this is a bit of a reference to the first test that we made for option A. So we are only using one context that's going to be shared in all of the nested coroutines. And so we start in the same way as for option A. We start with the blocking scope, and then we go and we launch other coroutines with the global scope. And in this case, we are still making launches, so we are still creating jobs, and we are also calling here a join. The difference here is that everything is part of the same context. So when an exception is generated here and we have the join here, we are going to be able to pick up this exception, and we're going to be able to report the exception. What we are not going to be able to do is to call this launch. The reason being is because they are part of the global scope and we are making this launch here and we are making a join here, this also means that nothing will continue. So this coroutine will not be able to continue until this coroutine is completed. As we give a report, so we say an error has been reported, what also happens is that this launch never finds its place because an exception has been thrown, and therefore we go straight up to here, and then we will get to the completion of our process. Let's see if this is indeed what happens. So let's launch the application again with all the other functions commented out, and let's start and see what happens. So as we can see here, we started our project. We started our process. We have a machine start. We have the curds, and then we're going to go straight into where the error is happening. We see here in yellow letters that we were able to catch the exception and we were able to report it. It also gets reported to the console, and then it goes straight to process has been completed. And this explains the difference between what's happening here and what's happening here, because here we have a different scope, and because we have different scopes, these two launches will happen, have run in parallel, and although the whole nesting is affected by cancellation. Cancellation happens in this case after the code has ran and after the global report has been sent, which is what happens here. So that's the main difference between the two of them. So in one case the order is not the one that we expect, and in the second case we simply just don't get the complete report. So A and B are not valid. Let's go to option C. So let's comment the other options out, and we're going to test async. So the async test is similar to option A. The difference here is that we are going to launch an asynchronous coroutine, and by doing this we are going to create a deferred object, which is something that we get here. This is a deferred, so this is a deferred object. So I can show it to you in the code. So if we make this a variable, we see that we actually have here if we specify the type explicitly, we have a deferred, and a deferred allows us to use an await, and the await allows us to get back the return object for this function. But we are not doing that here. We're just launching a coroutine and we are generating an exception. When we generate this exception, since this coroutine has been launched asynchronously and we are not waiting for it to return, the exception simply just disappears. We don't get it in the logs and we are not able to catch it. So this run catching here is completely useless. So we will not report the exception, and we will jump straight into the report. So this one will generate a very simple console output, and the exception will not be observable in the logs. Let's start this test as well. Let's run it. And as you can see, we start the machine, we start the cheese cards, we make the report, and we let it sit. It's also curious, and something that I didn't mention yet, is that as we make this test, we see that of course we have two different coroutine scopes. One is dispatches IO and the other one is launch, and they are being launched, and these two run in parallel. And what we see here happening is that the let it sit happened after the global report has been sent. So this is definitely also not a good option. A, B, and C are not the options we are looking for. And of course, by exclusion, we can also deduct that option D is the correct one. But let's see why is that. So we comment all of the other options out, and we're going to go to the option D, which is the async and wait solution. The async and wait solution, what it does is essentially a bit more than what option C was doing. However, here we are just adding an await, and by doing an await, we are causing this whole coroutine, we are causing this deferred job to wait for a return value. In this case, our return value will just be, if I'm correct, it will be a job. And why is it a job? Very simple. The job comes out of the launch. So this launch is the reason why we have a deferred for type job. So here we are going to await for that return value. And as we await for that return value, nothing here will be launched, which now starts to match with what we want. Because we are waiting for the return result, we are also waiting for the exception to be caught. So we will get the exception and we will report it. So that's what we have here, report exception. And then finally, we're going to launch the global report. And at the end, we're going to complete the process. So this is our correct option. Let's run it and see how it behaves in terms of the console. There we go. So we see that the machine starts, we get the CRUDs, we get the cheese CRUD, we let it sit. Then something happens and an error will be created. It throws the exception gets caught. The error has been reported. We get the exception, an error has been generated. And finally, we make the global report, and at the end, we complete the process. So this is why option D is the correct one. Now, if we look at the 4 different options, they are all running examples and they all highlight the difference of when and how should we use an async and a launch, and how coroutines behave when we change their context. It doesn't give you the full perspective of how coroutines actually work with the different context and different scopes, or how the context gets transferred between nested coroutines, but it sure does highlights the difference between using async, launch, and everything here that we have seen is also an example of something that in coroutines is called structured concurrency, and structured concurrency is something that coroutines offer out of the box, and it is this whole story about putting one coroutine inside another coroutine inside another coroutine and having either deferreds or jobs working for us together. It offers a glimpse about cancellation, but that is something for another video. For this video, I only want to say that I hope you enjoyed it. I hope you enjoyed doing the questionnaire. I hope you were able to provide the correct answer. And if not, I hope with this video I was able to help you with questions you may have about Kotlin coroutines, structured concurrency, jobs, deferreds, async, launch. And if you enjoyed this video, please give it a big thumbs up. And if you've been enjoying my channel so far, please subscribe. I will be posting more videos soon. And if you want to know more about how to build a web reactive application using Kotlin coroutines, please click here. If you want to be challenged and participate in different quizzes, please click here. And if you want to know their answers, please click here. Thank you so much for watching, and until the next video, keep it graceful and stay sharp.